So in your review packet, I think it was page 9, right? Yeah. So, yeah, the very back of the review packet, I want to get through this whole sheet because this is a pre-test. So by the time we've gone through this whole sheet, we will be ready, hopefully, for the test. So we have already been through, and we can do more, but I want to finish this first. We've already been through 6. We did 1 through 6 already. So now we're getting ready for number 7, which is a huge problem. But do you remember, just from what you've done before, that some of the ones in number 7, A through K, are probably not going to be able to be done? Do you remember that? Sometimes they're not possible. So let's, before we get too far into this, let's make sure we can even do it. So I'm on page 9 of my review packet, which is the very back page, very last thing. I'm doing number 7A, and it says 2 times B minus D. Is this possible?
Yeah.
Yes, it is. Because isn't this a 2 by 2? And this is a 2 by 2? And the rule for subtraction is that they have to be the same size. Right? That's the rule for subtraction. Looks like, are we all here today? Oh, this is awesome. Okay, so here we go. What's 2 times this matrix?
1.
No.
Or, I mean, 2. Negative 2. 2, 4.
Yep. And I'm going to subtract this one. So I'm going to subtract entry, the corresponding entry. So 2 minus negative 1. Negative 2 minus 5. 2 minus 0. And 4 minus 1. There it is. Done, done, done. What does the second one want me to do? Find the inverse. Now, that is not always possible, you guys. What is the rule for inverses? They gotta be square. Is B square? Yep. So I can find its inverse. What are the steps I go through?
Switch the 1
All right.
and 2.
So I'm gonna make a new matrix by switching these two,
And then flip the signs of the other.
and that becomes negative 1, and that becomes positive 1. Now, that right there is not the final answer. That's a piece of it. You have to do that. But what's the other piece? You can't forget this.
You gotta like subtract the 2 different things and you gotta divide it by.
I gotta find the determinant.
Yeah.
So the determinant here is going to be 2 minus negative 1. I got 3. 2 minus negative 1. You okay with that? Then I take that 3 and divide everything by 3 in my new matrix that I built. And that is my inverse. This one does not have any simplifying, but sometimes they do. Make sure that when you write your answer, final answer in the answer blank or whatever, that you have reduced. Okay? How about problem C?
Not possible.
Not possible. That's an empty set because you have to be square to have an inverse. D, determinant of A. Okay, A is square, right? So it has a determinant.
You gotta have 2 places columns. Or rows. Columns, right?
So yeah, so we're gonna add the first, or not add, but
Or like
you
put them
know,
over
cut and
there.
paste. And when we do this, you guys, please make sure, everybody listen, we take the first 2 and we cut them out and paste them here. Don't change anything. Some of you are getting wild and wacky. Okay, now we multiply these together and get 5, 0, -2. So the total of these diagonals, remember you multiply, 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 add, I got 3. I'm gonna turn around and go the other way. 0, 3, and 10. So I got 13. Now what do I do with those two numbers? Subtract. So the answer is 3 minus 13, which is -10. The determinant value is -10. All right, everybody with me? Kara, can I get a nod? Or a shake or something?
Sorry, I just zoned out so hard.
All right. The determinant of C, this is question E. The determinant of C. Not possible because the matrix is not squared. You can't do a determinant, you can't do an inverse unless the matrix is squared. All right, don't let me trick you because you know I'll ask that question. All right, determinant of D. Can I find the determinant of D?
Yes, ma'am.
You can, and in fact, most of you could probably just do that one in your head. What is the determinant of D? -1. Technically, it's -1 minus 0, so that's -1. All right, letter G. B, that means times, B times C. Before I write it all out, what are the dimensions of B? 2 by 2. What are the dimensions of C? Oh gosh, I guess I'm gonna have to write it all out because it's doable. So B, 1, -1, 1, 2, and C, -1, 1, 5, 0, 3, 2. All right, so not only does this tell me it's doable, but it also tells me that my answer is going to be another 2 by 3. So you don't have to put these boxes in here, but you do have to recognize you are going to be finding 6 numbers, 2 rows, 3 columns. This top row of numbers is found by using this top row right here. So we have 1, -1, 3 times. We have 1, -1 for the first column. We have 1, -1 for the second column. And we have 1, -1 for the third column. So we multiply and add. So it looks like -1 plus 0. 1 minus 3. And 5 minus 2. How does that top row look to everybody? Don't let me make a mistake. Does that look okay? All right, now I'm going to do exactly the same thing, but I'm not going to use 1, -1. I'm going to use 1, 2. With the first column, the second column, and the third column. And I think that's my answer right there, if I haven't made any careless mistakes. feel like I'm in church. Can I get an amen here? Are we good?
Amen.
All right, here we go. All right, H, C times D. All right, before I write it all out, what are the dimensions of C?
2 by 3.
2 by 3. D is a
2 by 2.
good thing I didn't write it all out
Good.
because
Not doing it.
not possible. So we skip it. No solution. So you're gonna, don't leave it blank, write write what I did, write can't do, somehow indicate it's not possible, okay?
Don't even think about the next one that's forward.
Don't even think about the next one.
You know.
C times A.
Nah, you can think about it. I think.
We can think, not just think about it, we can do it. Because what are the dimensions of C? 2 by 3.
Backwards. Yeah,
What are the
Come on,
dimensions of A? 3 by 3. So we can multiply those two. So here's C, here's A. So negative 115,032. All right, I tell you what. I want you, this is exactly what we just got done doing. The answer is going to be another 2 by 3. I want you to work on this. I'll do it too, but I'm not going to talk. I'm just going to do it. You do it, and then we'll talk about numbers that don't match. Okay, but I want you to get some practice here on your own multiplication. Remember, it's rows of the first, columns of the second, guys. It's gotta go that way. Rows of the first, columns of the second. Peter, you moving along with me? Why?
I'm not.
I know, come on. The only way we get good is to practice, and the only way I know if I'm right is if you match me.
That means I have to get it right too.
You will. I have great confidence in you. Am I right?
That's what I got.
Okay, then I'm right. No question about it. We're good to go.
That's a lot of faith in this board.
We are good to go.
That's a little too much faith in this board.
Who did not get one of these numbers? Do we need to talk about how we got these numbers, any of them?
Can you talk about how you got the one?
Which one?
The one?
This one right here?
Yes.
That is first row, first column. So we take our first row of numbers times our first column of numbers. Negative 1 plus 2 plus 0. Right? All right, what does H-I-J, what does J mean?
It's transposed or something
The
like that.
transpose, that's right. And the transpose, we take our original matrix, which is this, And when we transpose it, that can be a big T or a little t. When it's written like an exponent position, it means transpose, whether it's capital or small. That means, look at row 1 and make it column 1. So write it as a column instead of as a row. And then do the same thing with row 2, write it as a column instead of a row. So the original matrix was 2 by 3. When you flip everything, it's going to become 3 by 2. Is that okay? And anybody remember what K means?
Transfer.
That means the trace.
Yeah.
Anybody remember what trace means? First of all, trace is another thing that only applies to squares. You have to be square. So we have inverse, determinant, and trace that only apply to square matrices. This one is square. Did you see that, those numbers right there? That's called the main diagonal of the matrix. Add them up. That's the trace. So the trace of this matrix is 7. None of the other numbers matter when we're doing trace. Only those numbers matter. Okay? Done. So all that was number 7. Whew. All right, now we're on to number 8. Find the partial fractions. Okay, you're good at this. You know what to do. Who can tell me what the first thing is I have to do if I am finding the partial fractions for this big fraction? Factor the denominator. That has got to be step 1, guys. What if it doesn't factor? It will factor. Factor the denominator. If it doesn't factor, it becomes a whole different thing. Yours will factor. Factor your denominator. Factor it correctly. Now what? So we know that that guy right there is going to equal 2 smaller fractions, one of them over x minus 4 and one of them over x plus 1, because this would be the common denominator of this problem, right? Okay. Now what? Lose the denominators. And just like any other problem, you lose the denominators by multiplying out the common denominator. So the common denominator in this problem is x minus 4, x plus 1. So if you multiply every single thing by x minus 4, x plus 1, and you do not have to write this step down, but understand this is what you're doing. You are multiplying everything by the common denominator. What happens is, it's all gone in the first fraction. Here, the x minus 4 cancels, so you're going to have ax plus a times x plus 1. And here, the x plus 1 is gone, so you have bx minus 4b. That is what you need to do. You need to get rid of the denominators. Okay, now what? I'm an equation. So my x's over here have to be my x's over here. So on this side, I have 6 x's. On this side, I have a plus b x's. So whatever, I don't know what a and b are, but they have to add up to 6 if this is going to be an equation. Similarly, I've got a negative 34 over here, and that has to be whatever a minus 4b is. These guys don't have X's. So they have to add up to the thing that doesn't have an X on this side. Okay? Now what? Substitute or eliminate. I gotta solve that system. And I eliminate all the time, but this one is just too good to not eliminate. Right? So I'm gonna multiply this by a negative. And I'm gonna have 40 equal to 5b. So what's b?
8.
B is 8. And if b is 8, it looks like a has to be -2. Now I want you to listen to me carefully. That is not the answer to the question. You have to make them fractions. So, -2, the way I set my problem up, -2 goes over the x minus 4, and the 8 goes over the x plus 1. Now, the reason that's a big deal is, when I factored this, I factored it in this order. Could I have factored it in this order? Yes, and if I did that, then I probably would have had A over this and B over this, which is perfectly okay. Because A and B aren't the answer, the actual fractions are the answer. So if you did it this way, your A and B are gonna be switched. But your fractions are gonna be correct. You're gonna have A over the right thing and B over the right thing. So please remember, this is your answer. Okay? All right. Sketch and show everything. Well, what's the good news about this problem?
No holes.
There's no holes, there's no factoring, so it's just pretty straightforward. So we gotta show everything. So tell me what we got. I hear you talking loud, but I can't understand it.
Is an asymptote at y equals 2?
I got a horizontal asymptote at y equals 2. I absolutely do. Y equals 2 right here. Y equals 2. Perfect. All right, what else do I have? Vertical asymptote at x equals 3. Because can x be 3? No. And cannot be, so vertical asymptotes. All right, what else do I have? Iowa?
Y-intercept at 0, 1.
I'm hearing a bunch of numbers floating around. Your y-intercept comes how? How do I get a y-intercept? I let x be 0. And if I put in 0, don't I get -1/3? So my y-intercept is -1/3. My x-intercept comes from the numerator. What makes it 0? What makes 2x plus 1 equal to 0? I heard someone say it earlier, -1/2. -1/2. Kids, an x-intercept is the x that makes y 0. If you put in -1/2, isn't y gonna be 0? Isn't that fraction gonna be 0? Yeah. Okay, can we tell what it looks like? What if I put that on my test paper? What's gonna happen?
You gotta use the other one.
You gotta use the other one. This is only half the picture. You have to have the rest of it drawn in there. Right? Even though you don't have any points over there, you know there's another half to the picture category.
So you just felt like pulling this back after the memory thing?
Huh?
You just felt like pulling it back out?
Well,
from the memory?
okay, because you remember that we did this back in chapter 2.
Yeah.
Well, this is a rational expression that contributes, it's the same idea as partial fractions, so it's all tied together in this chapter again, but you're exactly right, we did this already.
Gotcha.
We did it already. Okay. Now, last problem. Okay, so here we go. This is going to be, you know what this is. This is one of our linear programming problems. So we're going to have some constraints. We're going to draw it, shade it, use colored pencils, all kinds of stuff. What's missing here that was here in the notes? The table. All right, so let's talk about the table. I don't know how many rows and columns it's gonna have. I'm just gonna set it up kind of like I did the other ones, and we can add to it or not use stuff if we don't need to. But now I'm getting the labels into the table. Once we get the labels in, then it's usually easy for everyone. We gotta get the labels in. So I'll give you a little hint. Let's read the actual question. How many bags of each brand should he purchase? Whatever the question is, which in this case is how many A's, how many B's, that goes at the top. So A's and B's are gonna go at the top. And we're gonna let X be the number of A bags and Y be the number of B bags. So there's nitrogen and phosphorus and this and that. Okay, all that's good. But the top labels are the question. Okay? And then this box is almost always going to be a total. Now, the other things in the problem are going to go here. So what are the other things in the problem? Well, I already told you. It's nitrogen and phosphorus and cost. Now, does that chart look familiar to the ones that I gave you before? Yes. So you can make your own chart. Just remember that what you're looking for is across the top. And then all the various other things go down the side. All right, so now we're ready to go. He needs at least 100 units of nitrogen. So where does 180 go? It's total nitrogen. 90 units of phosphorus. Brand A is $10 a bag. It has 4 N's and 1 P. Brand B is $5 a bag. It has 1 N and 1 P. We can pay at most $800 for fertilizer. So the total cost, $800. How many bags of each should he purchase to minimize cost? What's the cost? All right. Who remembers what we do now? Make our constraints. In other words, we know eventually we're going to be graphing. The constraints are the things that we graph. So, usually the rows of the matrix give you your constraints. So what does that row right there say? 4x plus y. Now, be careful. He needs at least 180. So what symbol's going to go here? Greater than or equal to. And that symbol is important because remember, after you get this all graphed, you're looking at where the shading overlaps. If you don't shade right, you're not going to have the right region. So make sure that you're slowing down, reading the words. All right, what's this one saying? I mean, greater than or equal to, cause he needed at least 90 of those, right? Yeah. And then what's this bottom one say? 10x plus 5y. Watch it. That one's less than or equal to 800. Why is that one less than or equal to 800? He can't go over 800. He can pay at most 800. Does it make sense to you that that one's below? Now, I'm always, every time I do one of these problems, I am maximizing or minimizing something. What am I doing here? Minimizing the cost. And the cost will be calculated with 10x plus 5y. Isn't that how much money I'm spending? So let's sketch it, see what it looks like. I think I'll use 10s. 10s seem like a good number to use here for, in terms of the scale. So here we go in red. I'm using 10s as my scale. If x is 0, y is 180. 1, 2, 3, 4, 5, 6, 7. There it is. If y is 0, x is 45. And I know my boards are already a mess, believe it or not, they were washed on Friday. These problems really make a mess. And where is that red line shaded? Out, right above and out. So I'm not looking at the triangle. Do not look at the triangle. That is not part of anything. Alright, let's do purple. These are both gonna be 90. And that one is also shaded up and out. So right now, what I'm looking at is all of this right here. Right?
Yeah.
So now on top of all that, I gotta put this one. So X is gonna be, 80. Is that right? X. X is and Y, I don't know. 800 divided by 5 is 160. Oh. Where is the green one shaded? Below. So I'm above red, above purple, and below green. So I think I am bounded by this. What do you think?
Yeah.
So the answer to my question is going to be one of those points. Well, shoot. I don't know any of them. So if you are comfortable with your picture, and you're gonna be able, actually, you're not gonna be very good either, because that's not a whole grid, that's just like line. We're gonna need to find these algebraically. So that point right there, this is good practice anyhow. That point is the intersection of red and green. So 4x plus y equals 180, and 10x plus 5y equals 800. That's gonna be this point right here. This point is going to be purple and red. So that point's gonna be 4x plus y equals 180. And x plus y equals 90. And this guy is purple and green. Now, what do I have to do to actually find that point, those points? System of equations, which means substitute, eliminate, Kramer's rule, inverse method, all those things we've talked about in this chapter. Use any of them. I don't care, whatever you're most comfortable with. Let's go ahead. Everybody do this. I'll do it. Take each of these pairs of equations and do what needs to be done to solve it. Please don't just sit there and watch me, because I'm gonna get mad. And I don't wanna get mad. Yep.
Can you explain, you might have just done this, but can you explain again, like, why you chose those equations? Like, I know, see that
Color
you got-
coded.
I know you got them from the constraints, so you just use the two equations, but instead of equaling, I guess I just don't understand that equation.
Well, I'm looking, I need to know where the red and green cross each other.
Yeah,
So the red and green equations are right here.
okay.
So the equation, I'm not interested in the shading, I'm with the actual line. So I take this equation and this equation, and I do substitution or elimination on them.
Okay.
Or Kramer's rule
Why
or
is it
something.
not the other points?
Huh?
That one.
I need the points that make the overlap shading, and I color coding so I know exactly which two lines to use to find each point. So I got 10 for X, 140.
It's negative 900 plus 800. So we get 10x for the 200.
Oh, so you have to do all of them, okay,
Gotta
okay.
find them all. Gotta find every corner point. Now, not every problem is gonna have this many. Sometimes we don't have to find 3, sometimes we only have to find 1 or 2. But this time we had to find all 3 of them. Think about it for a second, guys. If I was shaded below, instead of, if this were the shape that I wanted right here, I would already have some of my corners. That would be the only one I need to find. But because my area happens to be out here, I need to do all those points. So I would love to have confirmation from somebody that you got any of those. Do any of those look like points that you got? Awesome. All right, this is all one problem, folks, but we're just about done with it. What's the last thing I need to do? Plug, okay, this means I'm buying 70 A's and 20 B's. So if I do that, how much is it gonna cost me? Okay, thank you. This means 30 A's and 60 B's. 400?
600.
700.
300.
600.
Is that 600? I don't trust you people.
And 600 is 400.
It's 6.
It is
30 times
600.
10 is, yeah.
Okay.
I think
And then how about 10 140,
800?
800 again.
So
Okay, so again, just so you understand, this means that if he buys 10 A's and 140 B's, it's gonna cost him $800. Okay? Now, what is he trying to do? He's trying to be economical, so he needs all of his nitrogen and phosphorus for the minimum cost.
So we're doing 30.
So we're gonna tell him to buy 30 A's and 60 B's, cause that'll only cost him $600. Alright? Okay, now, so we've been through this entire sheet, so we have practiced everything that is on Thursday's test. While you are looking through the rest of the packet, so that you can ask me a good question, I am gonna hand out your chapter 9 materials. These are your chapter 9s, so you're gonna put these away, but we're not done. Your job right now is to be finding questions. Okay, that's your job.
Sorry.
I need to talk to the class. Okay, nothing bad. That on my part. All right, here we go. All right, so everybody got a homework packet? All right, here come the notes. Remember, you have a job right now. You should absolutely not be on your phone. You shouldn't be talking about the phone. You shouldn't be discussing whatever it is you discuss. You need to be finding a review question for me to do. All right, everybody's got notes and homework. And I now am ready for your questions. So who's got one for me? In your packet, we have found something that we need to practice. Yep, page.
Number 2 on page 4.
Page 4, number 2. All right, page 4, number 2. Solve using the inverse method. Okay, now you guys, listen, pay attention here. We just got done solving systems of equations. I did what I always do, I eliminated. You might have substituted, who knows what you did. It didn't matter, you're on your own. For this problem, it is exactly the same situation, but now we are being told that we have to use the inverse method. All right? This is a no calculator problem. We're going to use the inverse method. The inverse method basically means you're going to multiply A inverse times B. That's what the inverse method means. Now, what is A? Well, A is the matrix of coefficients. 3, negative 1, 2, 1. That's matrix A. B is the constants. So B is 13, 7. You are going to find the answer by finding the inverse of matrix A, we've already talked about that today, and then multiplying it times that, we've already talked about that today, and that's going to be your answer. Okay? So, what is the inverse of this matrix going to be?
Well, you gotta find the determinant.
Gotta find the determinant, so the determinant will be 3 minus negative 2. 5. So the determinant is 5. And then what?
And then you wanna flip.
Make
or
a new.
switch.
So 1 and 3 positive 1, negative 2. There's my new matrix.
And then flip the sides.
Yeah, I did that on these guys, yep.
Oh, yeah, you did. Okay.
And then I'll divide everything by 5.
That's it.
And that is the inverse. So 1/5, 1/5, negative 2/5, 3/5. Now, this is not the answer to this question. This is the answer to the question that says find A inverse. Here we're using the inverse method, which means I have to multiply that times 13/7. I'm not going to freak out. It's row by column. Okay, so 2 by 2, 2 by 1, I'm gonna get a 2 by 1 answer, okay? So I'm gonna take 1/5, 1/5, I know they're fractions, don't panic. 13 and 7. Now they have a common denominator, perfect. Multiplying these is 13 over 1 times 1 over 5. Isn't that 13/5? And 7/5? 13 and 7 makes 20 over 5 is 4. Then I'll take negative 2/5 and 3/5 times 13/7. This is going to give me negative 26 and positive 21. Negative 26 and positive 21 is, yep, negative 5 over 5, negative 1. So what's the answer to the system? 4, negative 1. Now, I am 100% with you. If I'm walking down the hall and I find a system of equations, I am not solving it this way. But part of my job is to make sure you know how in case you want to solve it that way. So that's how you do it.
Martin's gonna have to be in order here.
Yeah. Anytime you solve a system. Because you're looking for that point right across. All right. You have my old page, you good with that now? All right, Nyla?
Can we do the first one on the same page?
Same page. First one is essentially the same problem. Look at it, but we are using a different method to solve it. How does Kramer's rule work? This is the inverse method. This is what you do with the inverse method. What do you do with Kramer's rule? You use all determinants. The whole thing is determinants. So we find the determinant of the coefficients, 1, 3, 4, 2. What is the value of that determinant? Negative 10. And that negative 10 is going to be the denominator of my answer. My answer is going to be an ordered pair, just like this. But they're going to be fractions, something over negative 10. All right, how do I find the numerators? I need to find, this is my x and my y. How do I find the numbers on top there?
Copy and paste.
Copy and paste. So for x, I take this determinant, the original one, but I copy and paste the 7 and the 8 in the x column. I leave the y column alone, copy and paste. When I do y, I do the same thing, but I copy and paste onto the y column, and leave the x column alone. All right, so what do I get for this determinant? Oh, I get negative 10. What do I get for this determinant? Negative 20. So like always, I'll reduce. It looks like the answer to this problem is 1, 2. We got time for one more. Let's do one more.
You do, the first page, like the little box.
Find the area of the triangle. Well, this is easier than you can imagine. Who remembers how we do this? So, first we have to build two vectors, right? Two directed distances. So, where you put the A and the B and the C is completely irrelevant. All right, you don't even need to draw it. The picture has nothing to do with anything. You need to find two directed distances. So I'm gonna start right here at angle A. You can start wherever you want, any angle, it doesn't matter, I'm gonna start with A. And I'm going to figure out the directed distance from A to B. It's called a vector, and I wanna know what direction, positive or negative, and how far. So if I go from 1 to 3, that's positive 2 for X. If I go from negative 2 to 4, that's positive 6 for Y. So the directed distance from A to B is, I go right 2 and up 6. Now, A to C. I went here, now I'm gonna go here. So that would be 1 to negative 1, minus 2, negative 2, and negative 2 to 1, positive 3. Now, one more time. I did AB, AC. You could do CB, CA. It doesn't matter. BC, BA, doesn't matter. Just pick a point and go. Once you get your vectors built, you just create a determinant. Don't change anything, just build a determinant and evaluate it. What is the value of that determinant? 18. And then you cut it in half, and that's the area of the triangle. So the area of this triangle is 9. Now we remember that depending on what vectors you use, remember you have options? Depending on what vectors you use, what order you put them in, this might actually turn out to be a negative value. Just make it positive, ignore the negative. So if this had been negative 18, I still would have made it 18 over 2. Okay? So that's the area of the triangle. All right, so here's what I need you to do for next time. We're gonna review one more time.